Hello retro fans! A lot of FPGASID adapters have been shipped already, and therefore I've got a couple of questions, or I have received a couple of questions about how to, well, assemble it. It's quite obvious, and there are already 2 videos about this, and how to install them, how to configure them, and how to use them actually. And well, I understand that this topic isn't perhaps as easy as some may think in the very beginning, but it isn't very complex either. But we may have to keep a couple of things in mind, and we have to kind of well, pay attention to a couple of things in order to get this working properly. And as a very first thing, I'm going to talk about the installation, so that's the mechanical part. And then we're going to talk a little bit about the wiring and the background of this whole thing. And then we're going to dig deeper into the configuration of the FPGASID itself, as well as of the Ultimate 64. And at the end, we will talk about address switching and usage scenarios. So that's basically the rough structure of this video, and hopefully we're going to stick to this. So as a very first thing, we may just start with the adapters itself. So as you can see, I have already installed 2 FPGASID adapter, and I have to admit the naming is a bit confusing because I have used a different naming at the very beginning of the project, and I got some complaints, so I later changed the namings of the adapters, but I kind of forgot to change the naming on the adapters itself. So it's confusing for myself as well. So for the next project, I really have to come up with something else. So basically the naming right now is that we either talk about the 1 FPGASID adapter or the 2 FPGASID adapter, and this refers to the number of FPGASIDs installed on the adapter. Both adapters are meant to use on boards with 2 SID sockets. So they work on the Ultimate 64 as well as on the Reloaded MK2. We just have to keep in mind that the order of the sockets is switched on the Reloaded MK2 or on the Ultimate 64, depending from which side of the street you are looking at this. But that's basically not a major thing. We just have to keep this in mind if we're going to configure some certain things. So basically the installation is quite simple. I mean, we have to add the FPGASIDs to the adapters, and we have to pay attention to those small pogo pins, which are perhaps not required for all of your usage or whatever, because the main reason for adding those pogo pins to the adapters is that we can get the audio signal from the first emulated SID as well as from the second emulated SID in the very same level, because the FPGASID is using 2 different levels like a normal C64 would do. So the SID outputs an audio signal at a certain level, and this is going to be converted by the board by a kind of a small amplification circuit, and then you have access to this audio signal from the outside of your C64. And the FPGASID is doing basically the very same, but if you may remember, we have an additional port on the FPGASID. This is this 2-pin connector here in between those 2 bigger ones. And here we have access to a signal similar to the one the C64 outputs. And this signal can't be used to route it back to the board, because the board is expecting a different audio signal level. And therefore this is not working on the Ultimate 64, for example, and therefore we need access to an unamplified signal, and this is available on the production model as well as on the prototype, but it has a different location on the prototype, so we need to refer to the production model. And here we have this very small pin, very small pin is very small hole, solder hole, or whatever we want to call this. And here we have access to the very same audio signal level like we have on pin 27, but for SID2. So that's the background of this pogo pin, and therefore we have the chance to have two audio signals at the very same level, and this makes much sense on twin socket boards like the Ultimate 64, or if we want to have access to the so-called raw audio signal or signals, and therefore this adapter can be used. Here we have access to 4 audio signal lines, first SID, second SID, first SID, second SID of the second FPGASID, and they have equal levels, and this can be used for music production or whatever, external mixer devices, something like this. So as I said, we need to place the FPGASID on the adapter, and we have to pay attention that the pogo pin really hits this little hole from below. A little bit hard to see, but here we go. And then the adapter is basically just placed onto the Ultimate 64 board. You have to switch it off, obviously, before you do so. And that's basically the main installation. So, and for the second adapter, so the one FPGA adapter, it's going to be the very same, just that we have only one of it, but we have the pogo pin here as well, as we can see in this adapter. And then we have to go through the very same procedure, and then we have to place the adapter on the Ultimate 64, like we did this for the first one. And what we can see here right now is that we have a difference in the wiring, and in the wiring, because the FPGASID is able to emulate 2 SIDs, and on a twin socket board like the Ultimate 64 or the Reloaded MK2, we have already all the signals required to work with 2 SIDs. And for this adapter, I have used kind of a small trick, because the Ultimate 64 generates the so-called chip select signal for the second socket by itself. And we can kind of, let's say, fool the FPGASID into a scenario that it is using this already existing chip select signal, and this adapter is doing nothing else than just getting the signal from here, from the socket, route this to this small pin, and here we connect the red wire of the FPGASID. Why we are going to do this, I'm going to explain this in a second. And this is basically all we have to do for this adapter. So the yellow and the black wire is not required for this scenario. So if you are kind of sure that this is the only one you're going to use, or if you just want to get rid of the cables, you can even remove them. So or you just build kind of a small loop, something like this, so that it's not going to interfere with something on your board. For the 2 FPGASID adapter, this is a little bit different, because the second socket is already used by the second FPGASID, so we can't use the chip select signal for additional SIDs, but we can use the wires provided with the FPGASID to get access to different addresses. And the main thing that hinders us to do so is that this P7 jumper is usually not soldered. So, but on pin 2 of this jumper we have the so-called address lines A5 or A8. More about this later. And here we can use, for example, the yellow wire for A5 or the black wire for A8. This has to be configured in the Ultimate 64 menu. But as I said, this is normally not the case, so we're going to ignore the scenario completely, because the intention of the adapters was to have a solder-free solution. But on the I/O port, we or on the expansion port, whatever we want to call this, cartridge port, we have the so-called I/O signals, I/O1 and I/O2. And these signals are generated by the board, usually when you write data to a certain address range. And these signals can be used as a chip select signal, and therefore we connect the red wire, as we did for the first adapter, to our expansion port to pin 7, respectively pin 10. And this kind of method has been used by people since the 80s, so to say. So this was probably the first version of using additional signals to play with more than one SIDs. If we just exclude stacking SIDs for a while, which is perhaps not a very elegant solution. But for example, Messiah is using this method as well. So the two SID adapter from 8-bit Ventures is using the very same method. It has some pitfalls. We have to keep in mind, we talk about signals from the expansion port, and we may use expansion cartridges, for example, which are using the address ranges, and therefore we will have some troubles if we're going to play music to the addresses. Then we may have issues with the cartridge and something like this, but that's probably not going to be a topic of this episode. So that much about the mechanical installation and the wiring of the FPGASIDs. Basically on the Reloaded MK2 it's the very same procedure. We just have to keep in mind that here we have 2 sockets as well, but they swapped, which is not an issue during the installation. We got access to the expansion port here as well, and we have access to the address lines on the CPU, for example, A5 and A8. So things are a bit more easier on the Reloaded MK2. And basically that's the whole difference between the two boards. And it's a little bit dusty. I have to clean it perhaps. So anyway, so we're not going to go through this in detail as well. And yeah, so much about the wiring. Then let's move on to some background of addressing and some configuration examples, and how we're going to use this. And I have prepared a small kind of presentation just to show you how this is going to work. And here we have a simple schematic of the internals of a C64. And if you are interested in more details, I have created a video about twin socket background, something like this, a couple of weeks, months ago. I will link to this video in the description section. So if you're interested in more information how this whole thing is going to work, then please have a look at this video. This is the schematics of a C64 using one SID. So we have our address lines, we have our data lines, we have IRQ and read-write. And the one thing I have talked about already is the so-called chip select signal, short for CS. It's a low active signal, so basically there should be kind of a small line above the CS letters, but I couldn't get this into my font, so therefore I left it out. And if we're going to add a second SID, then it is required to provide more information. We cannot use the very same chip select signal for the second SID, then both SIDs are going to play the very same stuff, and this is not the intention of the whole story. So we have to create a second chip select signal, and for this we can use the so-called address lines A5, A8 or the IO lines, and there's a small difference which I'm going to cover later on. And we need some kind of logic in between, that kind of distinguish between chip select 1 and chip select 2. This is covered more in detail in the video I have mentioned already. So we're going just to skip over this part. We just keep in mind we need 2 chip select signals. So, and here we come to the so-called address ranges. The SID has access to 5 address lines, A0 to A4, and this provides a address range from, as it is built, from D400 to D41F. And we will see later on that the D and the 4 is built with additional address lines, but that's not relevant for the SID because it can see only A0 to A4. And using the so-called read-write signal and the chip select signal, the SID knows when the data is meant for it or if it is meant for something else on your board. And as we can see, if we want to use a second SID address like D420, then we need an additional address line, which can be A5, for example. So this is how this whole thing works and why we need a special kind of technical implementation to use more than one SID. If we move on now, we can see that the schematics we have seen a couple of pages ago is using A5 as a signal, and we have a difference between D400 and D420, and this is a A5 as a single bit. So, and there's some kind of small logic in between that kind of bundles the information and creates the chip select signal. And what we can see here right now, that the data or the addresses, well, built by our address lines between A0 and A4 are the very same. And this is the reason why we need an additional signal to distinguish between the addresses, because the SID has only just 5 address lines. So moving on to a much bigger table, here we can see the whole address ranges from A0 to A15. So the C64 has a 16-bit address bus, so to say. And what we have to pay attention to is A5 and A8, and we can see that there are some differences in addressing, but what's really important for our video today is the address range DE00 and DF00, so the last 4 lines. And I have just filled the ones and zeros where there are differences and where we have a new line, so to say, just to keep it a little bit compact. And as we can see, the range from A0 to A4 is almost the very same. So voice 1 is always on 00000, regardless of the base address. And the base address is built by either A5 or A8, or later on by additional signals like the IO signal. So let's move on. And here we have a schematics of the installation of the single FPGASID adapter. And here we can see socket 1. All the information is kind of transferred to SID 1 of the FPGASID, and we use the chip select signal from the socket 1. And the information from socket 2 is basically the very same, because address lines are the same, the data is the same, IRQ read-write is the same as well. But there's a new chip select signal, and this is routed by the red wire to the second emulated SID by the FPGASID. And by setting the second socket to a different address, the Ultimate 64 will generate a new chip select signal. And that's the whole magic behind this. And since the red wire of the FPGASID expects a low active CS signal, we can use the chip select signal of socket 2. And that's basically all we have to do and all we have to know, and everything is working fine. And this gives us the chance to change the addresses by the configuration of the Ultimate 64 without even touching the configuration of the FPGASID. And this is pretty comfortable because we can do this on the fly. So the next thing is the twin FPGASID adapter. And here I have changed the order a little bit just to reflect the numbers in the picture as well. So socket 1 and socket 2, oh, I have a mismatch with the socket numbers. So I should have changed the numbers of the sockets as well. I may have to correct this. But basically, this is the very same thing, but the chip select signal from socket 2 can't be used anymore because we use this for the second FPGASID. So we have to come up with a new solution, and this is probably going to get the signal from somewhere else. And the somewhere else is this big question mark in the middle of the picture. And what we can see here right now is that I have attached the red wires to the expansion port, to the pins I have mentioned already, 7 and 10. And the Ultimate 64 is generating kind of an CS signal when some data is written to the address ranges DE00 or DF00. And we can use this to tell our FPGASIDs that the data is meant for it. So, and that's the whole thing about the red wire. And since we have no access to A5 or A8 on a standard Ultimate 64 board, we can kind of, well, exclude the scenario at all. So moving on, we can see what I have talked about already. A5 or A8 could be available on P7 if you solder it kind of connector there. But we have IO1 and IO2 on the expansion port on pin 7 or on pin 10. And those signals generated by the C64 board are indicating that data has been written to a certain address range, and we can use this as a CS signal. And now I have some configuration examples. We're going to dig into this in a kind of a live session in a few minutes. And what we can see here right now, the one FPGASID adapter is set to socket 1 address D400. That's the base address, and I recommend to use this for the first address all the time because this makes things a lot easier, and it's not going to be confusing or kind of interfering with other configurations. So, and the socket 2 address can be used or can be set to any address you want to use for your whatever, playing tunes, playing demos, something like this. So we can use it for the standard range, D420, 20 or D440, or even D500 or something in between. And we can set this to DE00 as well as DF00. So I have a couple of dots there because there are many possibilities. You can basically use any address provided by the Ultimate 64. And I recommend avoiding using address ranges. The Ultimate 64 offers you the chance to use an address range like D400 or D2, D7FF. But we have to keep in mind this is required to configure the FPGASID, and I'm going to talk about this quite soon. But if you want to play tunes, please avoid using address ranges, and this is quite obvious if we set the first SID to address range, like mentioned here, and the second SID to address D420, then the first SID is trying to play the very same stuff the second SID is going to play, and this is going to sound quite, well, distorted, kind of, well, not very well, to make it short. And if we move on to the second FPGASID adapter, here we have almost the very same scenario, but since we're going to get the addresses DE00 as well as DF00 from the expansion port, I recommend not to use those addresses for the base addresses. So set your socket 1 address to D400 as usual, and socket 2 address can be anything between D420 as well as higher address ranges, but avoid DE00 as well as DF00. So now about the configuration itself. If we have the very same base address for both sockets, say socket 1 is D400 and socket 2 is D400, then both first emulated SIDs by the FPGASID will play the very same information. And this is basically not a problem because they should be in sync. I mean, they get their information at the very same point of time. But this will lead to an increased volume because now two SIDs are playing the very same thing and the other voices are played just by one SID, for example. And therefore you will have some imbalance of your volume. So keep this in mind. So if you want to play a demo, let's say that is using D400 as well as DE00 and DF00, then simply set the socket 2 address to D420 and the first emulated SID of the second FPGA SID will not play anything at all and everything should be fine. So theoretically, using these scenarios, we can play tunes or demos using addresses like D400, D420, DE00 and DF00. So basically quad tunes should be possible as long as your software, your tune, your demo is supporting those address ranges. Unfortunately, we kind of, bond to DE00 as well as DF00. So the quad tune from the quad demo can't be played on the Ultimate 64 out of the box because we cannot change the address DE00 and DF00 because they are given by the expansion port. And I couldn't find any solution to get this demo running on the C64 except for using the ALDI-SIDs, which is not a bad thing at all. They just sound a little bit different, but here you have the chance to set them to any address you want, like DE20 for example, which is not possible in our scenario right now. So I hope this is kind of understandable and not confusing even more, but I think if you go through this a couple of times, if you play with this, then it isn't really very complicated. So, but as usual in every story there has to be a but, and the problem here is that if we're going to switch back to our normal view, there is actually an issue with the Ultimate 64 using the IO1 and IO2 signal. I have kind of downgraded my Ultimate 64 to an older firmware version because the last at least 2 firmware versions are kind of disabling the IO signals on the expansion port while playing music. And I have prepared a short video just to show you what's going to be the issue. So this is a Reloaded MK2 and the signal from the IO1 of the expansion port kind of visualized by my oscillator, and here you can see where I get the signal from, that's pin 7. And the Reloaded MK2 is playing a 2-SID demo, and we should have some IO activity on the Ultimate 64 as well, but there is nothing. So the signal stays high all the time, and therefore we are not going to hear anything of the second voice emulated by the FPGASID. So initially I thought perhaps I have broken my expansion port, so I was testing a game cartridge which is using the IO signal, and here we can see that I have captured a low signal on the IO1 pin 7 on the expansion port. So the expansion port is working fine. So I started to dig a little bit deeper, and as I said, I downgraded my Ultimate 64 to an older firmware version, and this is probably one of the first firmware versions I have received board with it, or it was one of the very first updates. And here we have activity on the IO1 pin. So in this scenario, our FPGA SIDs are working very fine, because this is how it meant to be. And as I said, if you're going to use an older firmware version, everything is fine. As kind of a, let's say, orientation point, my impression is that the firmware version that was able to use the RGB LED connectors, or RGB LED light on the user port connector, was the very first version that's not working. And yeah, I'm just testing a different demo using the very same method, and a different firmware version as well. Oh, I think it's the very same, yes. And here we have a full level of I/O activity, and if we stop the demo, then this I/O signal is gone. And if we go back to the demo, the I/O signal is already there. So basically, right now, if you have the most recent firmware on your Ultimate 64, you cannot use addresses DE00 as well as DF00 on this FPGASID configuration. And this is a little bit sad. I have communicated this to Gideon just to see whether he comes up with an idea or what's the reason of this behavior. I mean, that's pretty unusual, because none of my 64s, whether it's an original board or if it's an individual computer's reloaded board, are acting in this way. And as we have seen already, the Ultimate 64 is capable of behaving like this, but it is not doing this anymore. So for the purpose of this exercise, I have used a different firmware where those I/O signals are still available, so that we can go through, let's say, the configuration of this whole system and how we're going to change addresses on the fly, for example. So as a very first thing, we have to have a look at our C64 screen. And if we go into our Ultimate configuration in the U64 specific settings, we have the section SID in socket 1, SID in socket 2. And here we have SID socket 1 address, SID socket 2 address. And this is the so-called address range I have mentioned already. And what I said already as well is, if we want to configure the FPGASID, we have to use this address range, otherwise it's not visible by Config Guru. And to avoid that, Config Guru is going to change the configuration of both FPGASIDs at the very same time, which will lead to some troubles. We set the second FPGASID to a very different address, like D4500 or even higher. Just to be on the safe side, we can even use DE00, for example, which is not related to our expansion port, so don't mix this up. And it is very important that we set pedal override to disable, because this is kind of required by Config Guru to configure the FPGASID, and this is kind of blocked by Ultimate 64 if we set this to enable, and probably not very important to cover this. And if you have done so, then we can simply start Config Guru, and here we have our configuration. And there's kind of a small bug in the Config Guru program. We cannot see whether the FPGASID is set to mono, pseudo stereo or full stereo. So we just have to go to export screen, and if we see that the SID2 has a different base address, then we know we are in stereo mode. And what I have mentioned already, we have to set the base address of the second emulated SID of the FPGASID to DE00 to use the red wire. And since we want to have the audio routed back to the board as a kind of a mix, because we have no external audio connected for this episode, we set output to mix, and that's basically all we have to do. And we do this for the second FPGASID as well. I have done this already, and I'm not going to mess up my configuration right now because this may extend the video a little bit longer than expected. So just assume that I have done the very same for the second FPGASID. So, and if you're going to step out of this, and then we're going to, let's say, go for a demo that is using 3 different FPGASIDs, we just have to do one thing. We have to set this back to an address we are not going to use, and to set this to an address which is not a range, as mentioned already. So, and now we can jump into the demo. And now we get a question, which addresses we are going to use. And as mentioned before, we're going to use DF00 as well as DE00. And hopefully everything is working fine, and we should get some audio somewhere. But there's no audio, which is indeed a little bit strange. So let me think for a moment what can be wrong. We are connected to HDMI, so the signal is coming through HDMI. And we should have some audio on the HDMI. So let's have a look whether we have an issue with our volume. Nope, volume is fine. But there is no audio. That's indeed strange. The FPGASIDs are playing. We should have audio on HDMI, but there is no audio on HDMI. Very strange, very strange. This is a little bit unexpected because this was working just a couple of minutes ago. So then let's have a look at the configuration. Digital video mode is set to DVI, which is probably the reason why this is not working. And here it is. We got sound. So, very fine. I think basically all we want to have. And as the next thing, we're going to test this with the one FPGASID adapter, because there we have a chance to do this on the fly and see how this is going to affect the playback of the sound. So I'm going to interrupt this, and we have to change the configuration of the user interface. Let me say overlay on HDMI. So now we should have very same overlay with interruption. And we're going to switch off our Ultimate 64 because we're going to change something on the board. So I'm going to remove the adapter. And those red wires. And let's put this aside. And now we install the one FPGASID adapter. Pay attention that we really hit the right sockets. The red wire is already connected to chip select. black and yellow is not required. And if we're going to start a system, we should come up with a picture. And here it is. Let's switch this to this view. And here the procedure is basically the very same. And for the purpose of this exercise, we just leave the addresses as they are. And we're going to start the very same demo, which probably makes not that much sense, usually, because we have just two SIDs emulated right now. But what I'm going to show you is how we're going to change addresses on the fly. So what we've learned so far is the first emulated SID is using the address D400. So the second SID is going to use D420, and the third is going to use D440. And we just start the demo as it is. And we already have some audio, which is perhaps a little bit loud, so let me just dim it a little bit. And let's see whether this is going to work the way I have planned it. So right now we listen to the sound sent to D400 as well as D420. And if we're going to change the address on the fly to D440, and step out of this menu, then we can hear that the sound has changed. And we can do so for the first socket as well. If we're going to set this to D440. And this is basically how it works. So the nice thing about this method is that we can do this on the fly. So if you jump into a game, or if you have a certain demo or something like this, and you just kind of recognize that this is going to use a different address configuration. Like if you're going to go into this one, we have one that's running on DE00, and this is fixed, we can't change this. And we have another one, this is running on D420, and we can change this either. And you don't want to go into config all the time. You can do this now with the Ultimate 64 by simply changing the addresses here for those two sockets. And as you have seen, this can be done on the fly. It's not causing any problems because the information the FPGASID is going to play is simply replaced by new information. This would be different if you're going to set the address to a range that is not used at all, because then the FPGASID keeps playing what was in the memory at the point where it has still access to the memory. But now no new information is coming, and therefore it sounds a little bit odd. So just keep this in mind that we have to use some addresses which are really making sense for playing back music. And well, yeah, that's basically all I have to say for this video. I hope it is really making some sense in a certain context. And as you can see, it's probably not as complicated as it sounds at the very beginning if you just keep some things in mind. And I really recommend watching the video about twin SID theory, background, whatever. If you want to have more information about this whole thing. And basically, if you just follow, let's say, some simple rules while working with the stuff, switch off the Ultimate 64 before you change something, before you connect something to some pins or something like this, and then basically you can't do anything wrong with it. So in worst case, it may sound horrible, or there is no sound at all, but basically you can't break anything. So at least I have no idea how this could be done. So perhaps there is a small chance, but I highly doubt this. So, and yeah, that's all for this episode. It's already long enough, and I think it was a lot of information, but I hope it is indeed helpful. If you have any questions, as usual, feel free to use the comment section, and I will hopefully answer them as soon as possible. There is a whole discussion thread at the forum 64 as well. I will link to this if you have some thoughts, ideas, recommendations, something like this. If something was wrong in my presentation, then feel free to express yourself over there as well. You can do this in German or in English or perhaps in other languages, but I'm having a hard time understanding other languages. So anyway, but it's not just a German forum at all. And you can find me on Twitter as well, and you can support me on Patreon as well as on Ko-Fi. If you really like what I'm doing here and you want to keep me doing this, then feel free to help me with some small things over there. And well, see you for the next episode. Thanks for watching. Bye bye.